Today we are going to talk about polar coordinates. Okay. Unfortunately, it has nothing to do with a polar bear, but it has everything to do with a pole. Okay. So we're going to talk about the definition of polar coordinates. We'll talk about going back and forth from polar coordinates to what we're used to, and we'll talk about equations as well. Okay. All right, so what we know right now is the rectangular coordinate system, okay? We have an x and y axis, and we move rectangularly, where the x coordinate represents how far we move horizontally, and the y coordinate represents how far we move vertically, okay? Now, just like with a lot of things that we do in math, sometimes a different method is better, okay? So in this situation, we're going to learn a different way of graphing equations and coordinates that could be more efficient in certain situations, okay? So we have a polar coordinate system, okay? This is our polar graph where we have concentric circles, okay? Our coordinates are r comma theta. Okay. R is representing the distance from the pole. Anytime I say the pole, that's in the same place as the origin. But when we're talking about a polar coordinate system, it's called the pole. Okay. So R, a directed distance from the pole. You can kind of think of that as radius if you want to. But directed distance, it could be positive, it could be negative. Okay, so if it's negative, we're moving backwards. Okay, I'll show you where. Okay, and then theta is our angle that we're going to rotate counterclockwise from the polar axis. Polar axis is what we like to think of as the positive x-axis. Okay, but when we're talking about polar coordinates and we're talking about graphing on a polar coordinate system, we are not talking about an x and y axis. We're talking about a horizontal and vertical axis. Okay. Only in rectangular coordinates do we have an actual x and y axis. You can think about them that way, okay, but on a coordinate plane or a polar coordinate plane, it is not the x-axis and y-axis. Okay. So you'll see that there's a bunch of concentric circles. That's how those are the units. Okay, instead of our squares. Okay, the circles is what we're going to follow along to count units. Okay, so if I don't rotate any, all right, and my r is 3, I move out to here. Okay, if my angle is 60 degrees, I rotate to here, and then I can move out 3 along those circles. Okay. Any questions about this right here? Okay, now, this picture that I have, I liked it because it had a lot of lines for the angles, but we are going to be working in radians. Okay, so don't get your hopes up about degrees. We're going to be working in radians. Okay. All right, so let's talk about how to graph. Okay, so if I were you, I would draw this picture in my notes. Okay, this is a pretty basic polar coordinate plane. Okay, the ones that you'll see, I'll have a 30-degree and 60-degree angle in there as well. But for now, the 45-degree angles are fine. Okay, what we're going to do is we're going to plot the point 3, negative 3/4 pi, and then we're going to represent that in different ways. Okay, so it does not matter whether you go your distance of r and then rotate it, or if you rotate it to theta and then go your distance r, I prefer to rotate first and then go out my r distance. Okay? You can do it however you'd like. So in this case, negative 3 pi over 4 is my angle. So here, what I'm highlighting in red, this is where we're rotating from. If I rotate negative 3 pi over 4, where am I going to end up?
Stop.
Third quadrant, correct? So here I am in the third quadrant, and we're going to go forward 3. There's the coordinate 3, negative 3 pi. What's another coordinate that describes that point? Okay, so I could write this as 3 5 pi over 4. 6 has the same as 3. If you're going to change it, it ends in the same place, but it is not the same angle. For negative 3 pi over 4, we had to rotate this way. For 5 pi over 4, we have to rotate counterclockwise. If they ask you for another way to express it, yes. Okay? Now, there's another way we could do this. What if I wanted a negative r? What would our angle have to be? Okay, what did you say? Okay, for simplicity, can I say pi over 4? Is that okay? Okay, just for right now, and then we'll talk about what you just said, okay? If I rotate to pi over 4, I am here, correct? And if we have a negative r, we would move backwards 3. Okay? Andrew also said negative 3, negative 11 pi over 4. Okay? Negative 11 pi over 4. No. Okay, you're thinking it's still positive 3. If you wanted a negative angle and a negative r, this would be negative 7 pi over 4. That would work, right? That's what I was thinking. Okay, there's lots of different ways to write a coordinate. Alright? Kind of nice. But make sure you know, does everybody understand the negative r? What? These are all in the same spot. Yeah. We just took our coordinate and wrote it a couple times. Okay? Alright. So, any questions? Okay. Now, you can kind of, maybe you can see the benefit right now of graphing these coordinates in polar form. Okay? If we think about like this coordinate right here, alright, in xy form, that's radical 2 over 2, radical 2 over 2. Okay, that wouldn't really be that great to graph on an xy form. Okay? But we do need to know how to go back and forth from rectangular coordinates to polar coordinates and vice versa. Okay? So let's look at the relationships that we have. Okay? Here I have a horizontal and vertical axis. And let's just say that this is my point, r theta. Okay? This red line that I'm drawing represents what distance? R. And theta is how far we rotate. Right? Well, we're going to keep it as counterclockwise. Okay? And I'm keeping it in the first quadrant just so we have an acute angle. Alright? Now, if I'm talking about that coordinate in terms of x, y, how do we get there? How do I, x, y coordinate, how do we plot it? Go horizontally x, and then vertically y. Oh, okay. So, polar to rectangular. I have my polar equation, or my polar coordinate. I want x and y. So if I know r and theta, how could I possibly find x? Which one? Cosine. The cosine of theta equals x over r. So x equals r cosine theta. If I wanted to find y, okay, the sine of theta is y over r. So y is r sine of theta. Okay, that's your conversion from polar to rectangular. Rectangular to polar. So now we have x, y. I want r and theta. How could we possibly find theta? Let's talk about the hard one first. The tangent of theta is y over x. And then r, I have x and y. Pythagorean theorem, x squared plus y squared equals r squared. Okay, any questions on those conversions? Okay, we're going to practice. I'm going to give you 2 of each kind. Okay, so first we have the coordinate 2 pi. This is in polar form. I want to get it to rectangular form. Okay. How do I find x? R cosine theta, right? What's the cosine of pi? -1. So x is -2. Y is r times the sine of theta. Sine of pi is 0. So our coordinate is -2, 0. We have done that one without those conversions. Let's talk about 2 pi. We rotate pi and move forward 2. Right? That one we probably would have been okay without the conversions. Okay? But it's nice to be safe, right? Let's look at the next one. Radical 3 pi over 6. This one we definitely need our conversions. Okay? So x is r cosine of theta. What is the cosine of pi over 6? Radical 3 over 2 times radical 3. And so then y is radical 3 times the sine of pi over 6. What is the sign of pi over 6? Times radical 3. So our rectangular coordinate is 3 halves radical 3 over 0. That was not so bad, right? Okay. When we are going from rectangular to polar, you need to keep in the back of your head what quadrant your coordinate is. Okay? You know that with our trig functions, tangent is positive in 2 different quadrants. Tangent is negative in 2 different quadrants. So you need to be conscientious of what quadrant you actually are in. Okay? So let's start with negative 1, 1. Alright? So we know that that is in the second quadrant. Alright? Okay, first thing we need is r. How do we find r? X squared plus y squared equals r squared. Correct? 2 is r squared, which means r is, okay, technically it's plus or minus radical 2, but I'm going to tell you right now, I prefer you to choose the positive radical 2, okay, just for grading purposes, okay, makes it simpler. Okay. Now we need a theta. How do we find theta? Tangent of theta is y over x. So when is the tangent equal to negative 1? Okay. And? Seven pi over 4. We're going to keep them positive. Okay. Okay, now, what quadrant do we need to be in? The second one. So if we choose the positive radical 2 for our r, what angle do we need to pick? 3 pi over 4 would put us in that second quadrant. Brushing up on our trig again, right? Okay. Next, we have the point 0, 2. This sits on an axis, doesn't it? When it sits on an axis, let's think about the picture. When it sits on an axis, we don't necessarily need to go through the plug and chug of our conversion. Okay? 0, 2. What's the distance to the pole? 2. How far did we rotate to get there? Okay. If it's on an axis, you don't necessarily need to do the conversions unless you absolutely want. Okay. But the picture is fine. Okay. Alright, how are we feeling? Great. Awesome. Okay? Now what we're going to do, we talked about going from coordinate to coordinate. Now we're going to talk about going from equation to equation. Okay? So, this is what I want you to do. Alright? First, we're going to work from going rectangular to polar with our equations. I want you to look for your substitutions. Okay? If you see an x squared plus y squared, you know that is r squared. Okay? You know that x is r cosine theta. You know that y is r sine theta. You need to look for those substitutions and use them when necessary. Hmm? Didn't we write down that y equals r sine theta? Okay. When you are solving these in polar form, I'd like them to be r equals something, unless the r disappears, and then you can solve for theta instead. Okay, but I would prefer that you solve for r. When we go through these examples, I'm hoping that you find some familiarity with the functions that we go through, with the equations right there. X squared plus y squared equals 16. What is it? It's a circle. A circle with radius of 4. Okay. Now, we need to get this into polar form. What do you see? You see an x squared plus y squared. You know that's the same as r squared, correct? Which means r is 4. Let's think about what this means in polar form. This equation, r equals 4. R is always 4. It has nothing to do with what theta is. No matter what theta is, our radius is 4. So no matter what angle we are at, our distance from the pole is 4. A circle with radius 4 centered at the pole, or at the origin. Well, this doesn't rely on theta. Okay? This is saying our r is 4 all the time. Okay? It has nothing to do with what theta is. Some of our equations will have a theta over here on the right side, but since this one doesn't, it just means whatever theta is, r is. Okay? Yep, that is our answer. R equals 4. Okay, so what I want you to kind of recognize, if you see like r equals 3, what is that going to represent? A circle with radius 3. Okay? What is this? A line. Now, we need to make substitutions, so this is in polar form. Do we have a substitution for y? Do we have a substitution for x? Well, let's go. We can do that. Okay, you're saying you want y over x equals 1? Yes, that would be fine. Okay, so keep that in the back of your head, and I'll go through that, what you just talked about. Let's talk about what we just did already. Okay? What could we do along those same lines? We can divide off r. What do you say about cosine? Okay, if I divide both sides by cosine, I'm left with the tangent of theta equals 1. Okay? Jamie's suggestion was, can you make this y over x equals 1, and then you can have the tangent of theta equals 1. Both get us to the same place. When is the tangent of theta equal to 1? (45 degrees, aka pi over 4 radians. Keep it simple. Pi over 4 is fine. Okay? So let's talk about what y equals x looks like. It's a line, right? Through the pole. That's the line through the pole at what kind of an angle? Short. Okay, pi over 4, right? So our equation, theta equals pi over 4. Notice how there's not an r in here? No matter what r is, we have rotated pi over 4. Okay, there's our line. Let's look at a line that does not go through the origin. What should I do? Add the 2 to the other side. Okay. Okay, we have substitutions, right? X is y is r sine theta. Our goal is to what? Solve for r. What should we do? There's 2 r's. You can add those 2 terms together. So what can you do? 2 terms have an r. Factor it out. Okay, now I have r times something. Okay, so here's an equation where r does rely on theta. Okay, whatever your angle is gives you a different r. Okay, which we haven't seen in the previous 2 examples. Okay, this is obviously not a more efficient way to graph this line, is it? This is the answer. R equals blah, blah, blah. Okay? Now, plugging in thetas to find R values is not going to be very efficient compared to what we have up here. Right? We can find a y-intercept, an x-intercept, and boom, graph the line. Right? Now look up here. I mean, just knowing that our line's at an angle of pi over 4, here's your line, that's pretty sticky, right? Maybe just as much work as y, I guess. But down here, the second example, this is obviously not a work. Okay? But this still represents the equation. Okay? All right. Last page. Let's go the other way. We have polar equations. Let's get to rectangular equations. Okay? I see r equals 2. We've already figured out that if r equals a constant, we have a circle. What's the radius of the circle? 2. So you can say, all right, let's square both sides of that equation, and then r squared is the same as, and there's our circle in rectangular coordinates with radius 2 centered at the point. What is this going to be? A line. Good. And it's going to go through, okay? In this case, it's going through the poles. Okay? Okay. So, how do we figure out what the equation is? Okay, let's think of this. What do I have that, what do I have a relationship with theta and x and y? It's the tangent. We know that the tangent of theta should equal y over x, correct? Well, in this case, theta is pi over 3. What is the tangent at pi over 3? Radical 3? How do you feel about that? So if I multiply x over, we have y equals radical 3x. Do you want to graph a slope of radical 3? No. Graphing a line with an angle at pi over 3 is a little bit better. Okay. So here's your assignment. I believe the first few, you're graphing coordinates. If you want to draw in your polar coordinate system and graph it all on that one graph, that is fine. You don't have to draw a separate one for each new coordinate. I think it's like the first 5 problems maybe. Okay? Remember tomorrow you need your graphing calculator.